Welcome to our STEAM project number 9, based on the BBC Microbit, the GeeekPi microcar and Microsoft MakeCode. In this lesson, we are going to add some extra peripherals to the robot car. These projects are for the absolute beginning STEAM teacher. We actually assume that you don't have any prior knowledge of programming, sensors, or actuators. We call this level the Scout level. My name is Peter. I am the founder of EdukoMondo and a certified STEAM instructor and course developer. In this project, we will explore what we can do with the extra connectors and buttons that we find on the robot car. We will activate the push buttons A and B to start and stop the microcar. We will add a servo motor, and we will control the speed of the motors through the use of a potentiometer. Now let's go to the Microsoft MakeCode and start our live programming. Welcome to our live environment, and we start by creating a new project. We give it a meaningful name such as robot car push buttons. And we are in the programming canvas. In this first part, what we want to do is to start and stop the microcar by pushing either the A or B button on the car. Pushing the A button will start both motors, while pushing the B button will stop them. And we also want to display on the OLED which button has been pressed. Because we are going to use the OLED, that will require the installation of an extension. And we'll go into the search bar and type OLED 12864, hit the magnifier glass and click on this extension. Now we know that using the OLED implies that we have to disable the 5x5 LEDs on the microbit. To do that, we go to LED, More, and we select LED Enable and move this into the On Start block. From the extension, we also need to initialize the OLED in the On Start block. So OLED 12864. And here on the top, I find the initiation function for the OLED. From the documentation of the microcar, we know that button A is attached to pin number 5, so remember that. In the forever block, we will have to embed a logic, and this true block, we are going to change that or replace it with a simple comparison. Okay. Now the first variable is going to be the digital read of that pin number 5. So I'm going to pins, take the digital read and replace the first 0 here with this variable, the digital read. It's not pin 0, but pin 5. If that reading is going to be a 0, then we want to show something appear on the OLED. We want to show a string, and we want the text to be that button A is pressed. Always good to add a short pause. Of let's say 1 second. I then want to clear the OLED display. And I'm going to use the clear function for that, which I find in the extension. And when we press A, I also want that the pins number 14 and 16, which we know from previous lessons are the 2 pins that will control the forward movement of the 2 motors on our microcar, I want them to be set to 1. So I go back to pins. I do a digital write. I copy paste it so that I can activate both pins 14 and here pin 16, and they need to be put to 1. They have to be set to 1. That's it for pushing button A. Now, if I want to stop the button B, then I have to activate the reading that comes from pin 11, because we know that button B is connected to pin 11. So what I will do is very simply control copy the full function that we already have created. And this time, if the digital read of pin 11 is going to be 0, then I want B pressed to be displayed, and I want the signal, the digital write, I want to set it to 0. That will stop both of the motors, and it will stop the car. So let's download this code and check it out whether it works. And this seems to be working quite nicely. In the next program, we want to attach a servo motor to the robot car. Servos are small DC motors that make an arc of 180 degrees. They are very small, lightweight, and are often used in remote-controlled airplanes, helicopters and cars. On the microcar, there are 2 external connectors linked to pins 8 and 10. So let's first connect the servo with the cable that contains a ground, a volt and a signal wire. Next, we have to create a new program, and we will call it robot car servo. Because servos are so popular, there is a dedicated servo function available under pins. That, of course, makes our life a lot easier. In the forever block, we will set pin number 8, servo write pin number 8, and we set that not to 180, but we set it to 0. We pause for a short while, let's say 5 seconds. And the next step is that we're going to send a new signal to the pin number 8, and this time we're going to send a 45 degrees signal. And once again, we are going to have a pause. Now, as you can see on the left side, there is already a virtualization of the program. And here you can see that the arm of the servo is going from 0 degrees to 45 degrees every 5 seconds. So let's download the program, and as you can see from the arm that I have attached to the servo, it is moving from a 0 degrees position to the 45 degrees. Let me show you another servo motor and a gripper that was made from Lego type building blocks. This kind of a gripper is often used in robotics to pick up objects and to move it to other places. And of course, as you can imagine, there are a lot more of fun applications that you can invent together with your classroom. That's it for the servo. Our next project is to add a potentiometer to control the speed of the motors. A potentiometer is a variable resistor of which the value changes by turning a dial or a knob. And we can add the potentiometer to the external connection pin number 10. So let me create a new project, call it robot car potentiometer. And we, first of all, we want to display the reading of the potentiometer on the OLED. So we know that we need an extension for that. OLED 12864. And we install it. We also know that if we want to make it work, that we first of all have to disable the 5x5 LED matrix by moving the LED enable function on the or in the on start block, and I also have to initialize the OLED with address number 60. Next, we want to capture the reading from that potentiometer in a forever block, and we want to display that as a voltage on the OLED. So we start by displaying a string at position x0 and y0, and we want to make sure that the viewer knows that this is going to be a voltage number that he or she will see. Now that we know it's going to be volt, we also need to add a number to be displayed, and that number is going to be displayed on the Y1 position. The number that we are going to display is going to be the analog reading from the pin number 10. However, that analog reading is not going to be in volt. It is going to be a value between 0 and 1023, which is reflecting the change in the value of resistance. To translate the scale of 0 to 1023 to a scale of 0 to 4, because the maximum voltage of our microbit is 3.3 volt, we use the map function. And we find that map function under pins. So the number is going to be replaced by this calculation. So first we need to map the reading of our pin number 10. So that's going to be an analog read. So go back to pins, and it's going to be the analog read of pin number 10. From 0 to 1023, so that's already good. And from low to high, it's already pre-populated from 0 to 4. Now, if I leave this function like this, the number that will be created will have a lot of digits behind the decimal point. Actually, so many that our small OLED display will be cramped by numbers. So we need to reduce the numbers that the function is going to return, and we do that by including the math function round. This is the one that I need. So I need to actually remove, first of all, this one again, and drop the round function first here, and remove it like this, and change the variable with our map calculation. That's it for the OLED display. The next thing we want to do is, of course, control the DC motors. To do that, you know that we will create a function. I'm going to make a function, and I will call the function, for instance, speed control. Now, this function, as you know very well, will contain the pins 13 through 16, which control the DC motors. So I'm going to quickly do this. So the analog write pins 13, 14, 15. So go to pins, analog write, copy paste it a couple of times so that I have 4 analog writes from pin 13, pin 14, pins 15, and pin 16. We know that it's pin 14 and 16 that we will be using. So 15 and 13 will be set to 0. And the value that I want to send as an analog signal to the pin 14 and 16 is actually the analog read of my pin number 10. So in pins, I'm going to take the analog read and change this to pin number 10. And I can copy paste this very easily and do it like this. Of course, the function in itself will not be activated unless I create a new forever block and I call the function speed control. I think that looks okay, so let us download this program. And as you can see, when I increase the power that reaches the DC motors, the faster they run, and it is also displayed on the OLED. Throttling down by turning the knob on the potentiometer will lower the voltage, and it will slow down the motors till the microcar stops. Isn't that nice? And that's it for these 3 additional projects. Here are some more projects that you can do with your class. For instance, you can use Lego blocks, the Lego blocks that you have in your classroom, to create other moving projects with the servo motor. Or you can replace the potentiometer with a joystick. In the end, a joystick is based on the same principle as the potentiometer. So the question is, are you able to control the car going forward, backward, left, and right through a joystick? That's it for project number 9, in which we were able to connect additional external peripherals to the robot car. This also concludes our projects where we have used the microcar. However, in our next project, project number 10, we are going to explore more projects with a microbit using a breakout board to connect sensors and conduct additional exciting experiments. Bye bye for now.